Okay, everyone. So, as you know, today our topic is solving simultaneous equations. Now, um, can anyone of you tell me what do we mean by the term simultaneous? What does it mean? Simultaneous means having it happening at the same time. Okay, that's a literary definition of the word happening at same time. Okay, what else? Risha, what about you? Hmm. Same values. Okay, a bit close. Ayan, what do you think? What do we mean by simultaneous equations? Okay, so same values times 2. So basically, you also believe that it means when you were solving from the perspective of simultaneous equations, I mean equations that give us the same value. But same values of what? Same values of what exactly, to be precise? Okay, so same values of x and y for two equations. Okay, right. So, yes, you're absolutely right, and this is what we actually mean by simultaneous equations, that we have two equations and we will have the same exact numerical values of x and y that satisfy each other. Now, let's have a look. For example, I have the equation 2x minus y equals 16 and 3x plus 2y equals to 17. Okay, these are two equations that I have. Now, I want to find the values of x and the values of y to an extent that I have such values that satisfy both of these equations, right? This is what I want. Am I right? Hmm? Okay, so there are two methods to solve it. The first one that we will study is my personal favorite, that is called substitution method. It felt a bit easier and satisfying. The other one was elimination method. Okay, now let's have a look. Solve it by the substitution method. Now, as we studied in the previous class, making something as subject of the equation, right? Now look at this first equation, equation 1, and this is equation 2. Look at this first equation and tell me what can be made as a subject of equation, y or x? Y, right? Okay, so can I write this in the form of 2x minus 16 equals y? I can, right? I can write it like this. That's great. Okay, so if I can write it like this, if the value of y equals 2x minus 16, can I input this value of y in the second equation? Can I write it like this? 3x plus 2 into 2x minus 16 equals 17? Most definitely, right? Why can I write it like this? Because, huh? Yes, this is, we are substituting that equation, we are substituting that value of y that we have in the form of 2x minus 16 into the second equation. Okay, let's solve it. 3x plus 2 into 2x is 4x. 2 into minus 16 minus 32 equals 17. Now what will we do? We will add the x terms together, 7x, and we will shift the non-x terms to the other side of the equation. 17 plus 32, right? Right. 7x equals to 49 and x equals 7, because 49 divided by 7 will be 7, right? Now we have the value of x. Now we need to find the value of y. What will we do? Yes, Ayan, your voice is not clear. Is my voice clear? I hope it's not lagging. Okay, okay, great, great, great. Let me just switch to another internet. Wait a minute. Okay, is my voice clear now? Good, good, good. Okay, so now we have the value of 7, a value of x in the form of 7. Can I substitute this value of x into this equation? This will be 2 into 7 minus 16 equals y, right? So we'll have 14 minus 16 equals, which is minus 2. Okay, so now we have the values of x and y, which is 7 comma minus 2, right? If I substitute these values of 7 and minus 2 into both of these equations, am I getting the right answer? Let's have a look. 2 into 7 minus minus 2 equals 14 plus 2 equals 16. So yes, I've satisfied this equation. What about this? The values of 7 and minus 2. 3 into 7 plus 2 into minus 2 equals 17. 21 minus 4 equals 17. Are we done? So this was the first method to solve the equation in the form of x and get the answers in the form of x and y. So this is called the substitution method. When we make, first things first, in most cases I'll write it generically. Make one term subject of equation. That's the first step. Substitute that subject, substitute that subject to the other equation, right? Understood? That's great. Write it down so that we can move forward. This is the first method basically. I'll erase this and then we'll try the elimination method. Are we done? That's great. Okay. Okay. Let's move forward with the other strategy that we have. Okay. The other strategy is called elimination method. Now, what do we mean by eliminate? Eliminate करने का क्या मतलब होता है? What do we mean by the term eliminate? It is to remove something, right? right? It is to remove something from its presence. Now, let's write this equation again once. 2x minus y equals to 16. 3x plus 2y equals 17. Now, I want to do one thing. What's that? Out of x and out of y, I want one constant that have the same numerical value. What do I mean by that? Now, 2 and 3, I can manipulate it in such a way, I can manipulate these equations in such a way that 2 and 3 become the same. But I have y and 2y. So I ask you this question. If I multiply this entire equation by 2, the first equation, equation 1 by 2, can I have this in the form of 4x minus 2y equals 32? Can I? I most definitely can, right? And I'll copy this down once again. 3x plus 2y equals 17. Okay. Now, look look at the left side of both of these equations. Can minus 2y be cut? If minus 2y and plus 2y are being perhaps algebraically manipulated, can these both be cut? Because minus 2y plus 2y is 0. And we have a positive sign here, which means that we are going to be adding both of these equations. If I have to add both of these equations, can I write it like this? Okay, so minus 2y plus 2y is cut. 4x plus 3x is, this gives us 7x equals 32 plus 17, 49, right? X equals 49 upon 7, which gives us 7. Again, are we reaching those exact values? Now we can put 7 in any of these equations. This, I personally would like to call it one steric. So like basically the steric signifies that there has been made some sort of a change to that equation. Okay. Yes, absolutely. So if I was to put the value of 7 in this equation, let's say 4 into 7 minus 2y equals 32, 28 minus 2y equals 32, 28 minus 32 equals 2y, minus 4 equals 2y, and y equals to minus 2. Did we reach the correct answer? I'm sure we did, right? This is what we call the elimination method, right? So one term is completely eliminated. Clear? Done? Okay, okay, that's great. Should I move forward? Let's solve another question. Whatever question we will be having, we will solve them in both methods, okay? So that I can make the concept clear. As of yet, which method seems more, quite a lot easier to solve? Substitution? Elimination consists of a lot of manipulation, by the way. So it's not going to be very easy always. Let's say we have the equation x plus y equals 29, 4x equals 95 minus 2y. Now, things look a bit easy for us. Let's solve it by first things first, substitution. What we will do, the first rule was make subject of formula. I want to feed my ego a bit. Let's make x the subject of the formula, right? So x equals 29 minus y. 4 into 29 minus y equals 95 minus 2y. What's 4 into 29? Good. 116 minus 4y equals to 95 minus 2y. Can we consider the y values at one side of the equation and the x values at the other side of the equation? I'm sure we can. 116 minus 95 equals 4y minus 2y. What's 116 minus 95? 21 equals 2y. And 21 upon 2, which is 10.5, gives us the value of y, right? Great. Okay, that's great. Now, let's input the same value of y within which equation do you want me to put it into? I'll give you people the time to decide. Generically, we can put it in any of them, but let me put it in this equation first, equation 2. This is equation 1, this is equation 2. Let me put it in this equation. 4x equals 95 minus 2 into 21 upon 2, right? So this 2 will be cancelled out by this 2, as simple as that, right? 4x equals 95 minus 21, x equals 74 upon 4, which becomes 37 upon 2. I'm going a bit too quick because I would expect all of you to be able to solve such types of equations. Like, I mean, basic algebraic manipulation should be done by you people quite quickly, right? Okay. Do we understand the question so far? Okay, that's great. Now let's solve the same question by elimination method. Write it down first. Okay, great. We have the same question in front of us, and what? Okay, never mind. Let's solve this equation by using method 2, which is elimination. First things first, that when it comes to elimination method, we must make sure that all terms are arranged systematically. All terms arranged systematically. X plus y equals 29. 4x plus 2y equals 95, right? Why it was important for us? Because we had to make sure that all of these are arranged in such a way that it's easier for us to manipulate. Let's try something new. Let's multiply the entire equation by 4. Okay, let's multiply the entire equation by 4. Should be. So this is equation 1 generically, but now I'll call this 1 steric, because there is some sort of changes made to the equation. So 4x plus 4y equals 116. And then let's write the same equation again. 4x plus 2y, equation 2 again, equals 95. Now I want to ask you one question. Here we have 4x plus 4x. Let's eliminate one thing. What should we eliminate in this case? 4x, the same terms should be eliminated, right? Minus sign in between. 4x minus 4x, cancel. 4y minus positive 2y. Yes, 2y equals 116 minus 95. What does that become? 21. And y equals 21 upon 2. Did we have the same answer when we were solving this method using substitution? We had the same answer, right? Absolutely, we had the same answer. Okay, right? So if we were to input these values, we would get the value of 4x plus 2 into 21 upon 2. What was the value of x again in this question? 37 upon 2. I think we're going to get that again, of course. 4x plus 21 equals 95, 4x equals 74, x equals 37 upon 2, as it is going to be 74 upon 4, right? Well done, amazing. Solve these questions, and let's solve a few more. I would prefer to solving at least one more minimum. Okay, done. That's great. Which one of the methods seem more easy? Yeah, out of the two, which one of them feels like, it's quite easier to solve? The substitution one, right? Yeah, because elimination consists of lot of manipulation. Okay, the other equation that we have, 3x plus 5y equals 4. 2x equals 3y. Now be careful with this. Now what should we do? What should we do now? Any ideas? Okay, so according to you, we should use substitution method first. So which means x equals 3 upon 2y. Okay, 3 into 3 upon 2y plus 5y equals 4. 9 upon 2y plus 5y equals 4. 19 upon 2y equals 4. Okay, your mental maths is quite strong. 8 upon 19. Okay, well, I mean, the answer is correct. But there is one more easier way to solve this. Your answer is generically correct, right? But there's one more easier way to solve this. First, you can write it down. Write this down first. Right? Written? Well done. Well and good. Okay. Now, this equation in the form of 2x equals 3y, can I write it like this? 2x minus 3y equals to 0. And I can consider this, not yet, as of yet. Can I write it in this form? First tell me. Okay. So 3x plus 5y equals 4 and 2x minus 3y equals 0. Well and good. Okay. Now what else should we do? Do you want to eliminate x first or y first? Be careful with what you do. Okay, let's try to eliminate y first. Okay, how would we eliminate y? Not in this. Hmm. How would we eliminate y? Okay, I'll tell you. What if we multiply both of these equations with each other? Which means I will multiply this equation by 3 and this equation by 5, which gives us 9x, this is equation 1 steric. 9x plus 15y equals 12. 10x minus 15y equals 0, because 5 times 0 is definitely going to be 0, right? This is equation 2 steric, the annotated version of the equation basically. Okay, should we introduce a positive sign in between? Okay, what happens to these minus signs? They're going to be cut, right? Okay, 19x equals 12 and x equals 12 upon 19, right? This is how we were meant to solve these questions. Any confusion? Okay, now let's put these equations, these values of x to this equation. Equation 2. 2 into 12 upon 19 equals 3y. This will be 24 upon 19 divided by, oh sorry, equals to 3y. And if 3 goes to this side of the equation, it's going to be divided again. So 24 upon 19 divided by 3. Yes. 24 upon 19 multiplied by 1 upon 3. This gives us 24 upon 57, or 8 upon 19. Oops, the battery is low. Wait. So did we have the values of y equals to 8 upon 19 first? This was the most difficult type of question that you might end up having, right? But you have to algebraically manipulate it to an extent that you could yourself determine what type of manipulation would we need. Do we need simultaneous equations? Would we need um sorry, when it comes to simultaneous equations, would we need to use the substitution method, or do we need the elimination method, right? So these would be the two methods. Any questions for today?